Hey, my name is Stephen Payne. I'm a senior here at Carolina, and in the fall I'll be going into my super senior year to wrap up my neuroscience degree. Once I finish with my undergraduate, I would love to go to pharmacy school, and that was largely brought on by taking Chem 101 as just a gen ed for my previous major. It changed my life. It made me more interested in chemistry than I had ever been. And that has only increased as I've taken organic, where I could actually start thinking about, drug design or synthesis, compounding, things that I would be doing in my future career. It's been an absolute joy to take these classes. And I would love to take the joy that I have and to bring it to other students to help them, even if it's not spark interest in chemistry, to bring the joy of understanding the content to them. There's nothing that feels better in a class than having an aha moment where you finally grasp the material, you're able to understand the concept, and then you're turning around and you're able to apply it. I know that I have had moments where being with learning assistants for 262 has helped me immensely. I was able to solidify my understanding and I grew my confidence in my skills. And that is largely what I want to do, is to help students have as many aha moments as I can, to provide them with the confidence in their abilities as they go on to take tests in this class, but also as they continue their STEM learning at UNC.
The problem that I wanted to do today is predict the products, where we have this benzaldehyde and we're given a set of three different reactions, three different transformations that we're doing, and after each one we'll end up with a final product. So starting with the acetophenone, we have acetophenone with NaOH and heat. So we know that the acetophenone has relatively acidic alpha hydrogens. The hydroxide can actually go in and abstract one of these, giving us an enolate. And the enolate can go in as a good nucleophile and attack our carbonyl carbon here, which gives us a beta hydroxy ketone. But because we have heat, it's important to remember that with the E1CB mechanism, we can actually drive off that alcohol and we can end up with a alpha beta unsaturated ketone. It also helps that this chalcone is an extremely conjugated system, so this is a very favored reaction. So now we can think about what our thiol will do with our chalcone. We see that we've got two places for it to attack, the carbonyl carbon or the beta carbon. Both are electrophilic sites. Our thiol is a relatively soft nucleophile. It's not a hard nucleophile like our hydrides or our Grignards. It's not going to kinetically prefer the carbonyl. It will thermodynamically favor this beta position. So we actually end up with a thioether on that beta carbon. Like that. Okay, and then we can think about our final transformation. So we see here for our third and final step, we have a secondary amine and trace hydrochloric acid. Now, when we have amines or nitrogen compounds and a ketone or aldehyde, we can do interesting chemistry where we replace this oxygen with the nitrogen. And after a few mechanistic steps aided by the trace acid, we can end up with a molecule that looks like this. So we'll have our ether, thioether here, and our nitrogen compound adds here. Now, this initially would be positive. To remove the positive charge, we can't abstract the hydrogen from the nitrogen, but we can abstract the hydrogen from the alpha carbon. And that gives us our final product.